Greetings. Welcome to W2U1, Merrill's first principles of instruction. This will be the first part. In the earlier unit, we presented an overview of instruction. The outcomes for this unit are understand Merrill's five first principles of instruction, part 1. Instruction design is concerned with the organization of appropriate pedagogical scenarios to achieve the intended instructional goals. These instructional goals are also called as learning outcomes or course outcomes or instructional outcomes and so on. The organization of the pedagogical scenarios in an appropriate way to achieve these intended learning goals is called as the instruction design. Such a design provides guidelines which can provide the basis for developing approaches to teaching. It's based on learning theories. Instruction is concerned with good learning by the learners. So, instruction design has to be obviously based on learning theories, how people learn. The models provide guidelines on what should happen during instruction. During instruction, teachers are involved and learners are also involved. So, the activities of learners and teachers, both these are covered in the instructional models. There are many theories, but we'll present only some of the popular ones. Merrill is one academic researcher who has worked extensively in the field of instruction design. His vision was to distill a set of interrelated descriptive principles for instruction design. We'll see that the keywords are interrelated, prescriptive, and principles. So, distill a set of interrelated prescriptive principles for instruction design. This was based on his extensive review of several instructional models that he encountered during his research. These principles may be present in different models with some variations in the terminology. The specific terms used to denote a concept could be different in different instructional models. The emphasis also could be different in different instructional models. There might be some principles which are in addition to the ones which are presented here. All these are possible, but Merrill's idea was to come out with a set of interrelated scriptive from the review of the instructional models. Principles are not in and of themselves a model or a method of instruction. The principles themselves do not constitute a model. Rather, they can be implemented by different models and methods. Merrill thought that for a principle to be considered as such, there are certain criteria that he wanted to adopt. His criteria were it is present in most of the instructional design models and theories reviewed by him. He wanted that to be a popular one, not a principle used in one or two rare esoteric models, but used in most of the instructional design models. And it must have good evidence from empirical research. That means it is supported by empirical research. It is general and universal so that it can be applied to all instructional practices. It is design oriented. That is, the principles offer guidance on how the instruction should be designed. Thus, they become prescriptive in nature because These principles are design oriented, and the principle must promote learning rather than describe what learners do on their own while learning. While learning, learners might be engaged in various activities of their own, but the Merrill's criterion was that the principle must promote learning. That was the basic criterion that he was looking for. After much review of many models, he distilled five principles and he calls them as first principles of instruction. These are task centered principle, activation principle, demonstration principle, application principle, and integration principle. Let us look at the task centered principle. It says that learning is promoted when learners are engaged in solving real world problems. The learning occurs in the context of solving real world problems. That will promote learning. Thus, a task centered instructional strategy promotes good learning. Many instructional strategies like constructivist learning, cognitive apprenticeship, etc., incorporate this principle. The concept of a problem in this principle includes a wide range of activities, including a simulated task. The task can be a simulated one as long as it has all the features of a real world problem and provides an appropriate learning challenge for the students. This activity is some whole task. That is the most important point that we should observe. Rather than only components of a task, and the task is representative of the class of problems the learner is expected to be able to solve. The task is a whole task rather than only components of a task, and the task is representative of the class of problems that the learner is expected to be capable of solving at the end of the learning unit. In contrast, topic centered instructional strategies typically teach all relevant component skills required to solve the problem before actually getting to solve the problem. So, while teaching the relevant components, we keep telling them, you will see its use later. So, a kind of, we'll get to how to use it later kind of a scenario. Whereas a task centered principle says that the instructional strategy starts with a whole task upfront. Right in the beginning, we indicate the task which is representative of the class of tasks that the learner is expected to be able to solve at the end of the learning experience. So, we show the task. Learning is promoted when learners are shown the task that they will be able to do or the problem they will be able to solve after completing an instructional unit. Course outcome or competency in the framework of outcome based education. This task is what we call as course outcome or competency. Learning from a task centered instructional strategy is enhanced when learners undertake a simple to complex progression of whole tasks. That is, it can be one single task, but learning is much better when we have a progression of tasks, a series of tasks, starting with a very simple one, and progressively the tasks are of increasing complexity. So, when the learner solves such a progression of tasks, the learning becomes deeper, much richer. That is the principle. One useful suggestion is that the first problem in the sequence could be a worked example that shows students the type of whole tasks that they'll learn to be able to do. Then we can have tasks with greater and greater complexity. Of course, depending upon the resources available and instructor's choice, the instructor may adopt a minimalist task centered instructional strategy, which would be a single task. In the framework of outcome based education, as we mentioned, a task is a course outcome or competency when the CO is elaborated further into competencies. The outcome based education or OBE is discussed in detail in courses like TAIL, NET, OBEA, or equivalent courses. A progression of tasks can be planned based on the CO competency. It is domain specific, and we will not spend time further on writing the COs or elaborating them into competencies. Those details would be available in the courses mentioned above, like TAIL, NET, OVEA, etc. Some examples of whole tasks, what we keep calling as course outcomes or competencies. Sort a given array of data elements using merge sort and quick sort. Obviously, these examples are all domain specific. One could look for examples in your own domains when you explore this topic further. A series of increasingly complex tasks. Example of that. The real world problem is ensure maximum power is transferred to the load in an electrical or electronic system. For example, an audio amplifier. It could be any system, but ensure the maximum power is transferred to the load. That is the real world problem, and that sets the context for the series of increasingly complex tasks that we expect the student would be able to solve at the end of the instructional unit. The first task in this series, the simplest task, a DC circuit with a fixed resistance, an extremely simple task. A more difficult task can be a DC circuit with multiple resistances. The next task in this series can be an AC circuit with complex impedances, resistive elements, inductive elements, as well as capacitive elements. So we can go on in the sequence like this. The next principle is the activation principle. Learning is promoted when relevant previous experience is activated. It has long been a tenet of education to start from where the child is. Even in elementary education. In fact, in elementary education, it continues to play an important role and is recognized by all the teachers. Somehow, in the higher education system, uh, we seem to feel that providing relevant experience prior to instruction is no longer necessary. Whereas learning is promoted when the relevant previous experience is activated. It is true for all learners because the prior relevant experience is not activated. It is possible that learners may lack or may not recall the previous mental models based on experience that can be used to structure the new knowledge. So, instruction jumps immediately into the new material without laying foundation for the learners, and consequently, learners generally resort to memorizing the new material presented. If the learners have required prerequisite knowledge, ensure that is activated so that it can serve as the foundation on which new knowledge can be constructed. Learners progress from where they are at present. That is, based on the foundation of their prior knowledge, they build on new knowledge. If the learners do not have required prerequisite knowledge, proceeding with instruction on the new knowledge is most likely to be ineffective. Learners are unlikely to understand. Learners are unlikely to have any deep learning. Perhaps learners resort to simply memorization or rote learning. So, ensure that the prerequisite knowledge is provided before introducing new knowledge. It depends upon the instructor's choice how this prerequisite knowledge is provided. There would be constraints, certainly, we agree, like time and other resources, but the instruction where the learners do not have the required prerequisites is almost sure to be ineffective. Ensure that learners recall, describe, or demonstrate relevant cognitive structures learned earlier. It could be simply recall a particular cognitive structure learned earlier, or the instructor might wish the students to describe it in a little bit greater detail, or in cases where the instructor feels the necessity, the learners may be asked to demonstrate the previous knowledge. Learning from activation is enhanced when learners share previous knowledge and experience with one another. If they can engage in some form of group discussion to discuss and share their previous knowledge and experiences, that would greatly enhance the activation's effectiveness. Such sharing provides vicarious experience to the peers and stimulates similar recollections in them. Thus, the activation principle can become more effective and learners would benefit more from the activation phase. Recalling or acquiring a structure for organizing the new knowledge helps the learners during subsequent demonstration, application, and reflection phases of instruction. We look at these subsequent phases presently, but in all those phases, recalling or acquiring a structure for organizing the new knowledge would be helpful. Examples: a task. Sort a given array of data elements using merge sort and quick sort. This is the example that we mentioned earlier. Now, what kind of activation of prior knowledge? Concepts of sorting. What actually is the idea of sorting? Ascending sort, descending sort. What are the practical contexts in which sorting would be required? And what is the importance of sorting? Then the concept of recursion and the concept of divide and conquer. Probably the concept of sorting and recursion are quite familiar to the learners. So we can ask them to recall, or we can ask them to discuss the context in which the learners used recursion. Perhaps their learners are not that familiar with divide and conquer, but they might make a guess. Allow them to express what they know about this concept, even if it is slightly inadequate. Let them engage in some discussion. So, instructor may direct learners to recall or demonstrate or engage in peer discussions and sharing, etc., as appropriate. It depends both on the instructor's choice as well as the background of the learners. Another example, determine Young's modulus of a given bar. What does the activation involve? Knowledge to be activated, concepts of geometrical moment of inertia, moment, momentum, cantilever, uniform and non-uniform bending. Again, instructor may direct learners to simply recall, for example, what is the formula for geometrical moment of inertia when it is a bar. So it could be simple recall, or it could demonstrate, or engage in peer discussions and sharing. A variety of tools and ideas and activities can be designed by the instructor to effectively implement the activation phase. The next principle is demonstration principle. Show me, demonstrate. Learning is promoted when the instruction demonstrates what is to be learned rather than merely telling information about what is to be learned. The instructor just informs the learners that this is what you would be learning. That is one way, but that is a poor instructional design strategy. We have to inform what is the task, but then it must be followed by activation. That must be followed by an actual demonstration of the way the task is solved. That is, the instructor shows the learners the solution of the task. And it must have some corollaries in order to be effective. Demonstration consistency. Learning is promoted when learners observe a demonstration of the skills to be learned that is consistent with the type of content being taught. That is, the learning objective, the actual content that is taught, and the demonstration, all of them must be in a way coordinated together, and they all must be compatible with each other, and they must be consistent. What the course outcome is, or what the skill is, and what is the content, they must be consistent. And the demonstration must be consistent with this type of course outcome. Learner guidance is another corollary. Learning is promoted when learners are provided appropriate learner guidance. We see that later learner guidance is extremely important. This has several components, we look at them. Then learning from a demonstration is enhanced when learners observe through media that is relevant to the content. We'll look at the possibilities shortly. Merrill distinguishes between information and portrayal during demonstration. Information is presentation of general principles and learners must be able to recall it. Portrayal is demonstration of general principles with a specific case, and learners must be able to apply the principles to any given case. So, while information is general, portrayal is with respect to a specific case, the application of the principles. Merely presenting information, a common form of instruction, is seldom effective. That is, information only instruction is most of the time ineffective. When information is demonstrated via specific situations or cases, that is, when instruction includes portrayal level, learning is promoted well. Demonstration consistency. Demonstration must be consistent with the intended learning outcomes for good learning. That is what we mentioned earlier, that the demonstration must be consistent with the competency that the students are expected to acquire. Learner guidance, it can include directing learners to relevant information using multiple representations for the demonstration, etc. Bring the attention of the learners to the key aspects, present the same concept using multiple representations. There are several ways that the instructor can help the learners grasp the content more effectively. So, this is part of the learner guidance. And relevant media is an extremely important aspect that promotes good learning. It could be simple text, or it could be an image, it could be a video, it could be a working model that is demonstrated in the classroom, it could be an experiment that is carried out in the laboratory, followed by an appropriate video. So, it is possible that we can have different media to demonstrate the task at hand. However, it's also important that these media do not divert the attention of the students from the task at hand, and they do not clash with each other. They should promote learning rather than distracting the learner. Learning from demonstration is enhanced by peer discussion and peer demonstration. Examples again, same task, sort a given array of data elements using merge sort and quick sort. So it can be show step by step working of merge sort to sort a specific list of integers, say some numbers like 21, 33, 113, 17, 42. Instructor could use pseudocode or code in a specific programming language like C. It depends upon rest of the instruction plan of the instructor. The instructional model to be used by the instructor is not part of Merrill's principle. The principle merely requires the inclusion of this phase. So, what is presented here is only a sample demonstration. The instructor is free to choose whatever appeals to him or her while demonstrating the problem. It could be present an animation video drawing attention to splitting the arrays and then merging them. The demonstration could include that. Then repeat the same specific problem of sorting the array using quick sort now. We have sorted earlier using merge sort. Now apply quick sort. Again present an animation video. Compare the working of the two algorithms. So the key features that the instructor would like to highlight during the demonstration and help the learners appreciate through learner guidance would be visual examples, not just code, problem worked out in detail, real-time tracing of the algorithm. These are all the aspects of demonstration that the instructor is planning based on the instruction model chosen by him or her. So, the lesson plan would include all these things. But that is all not part of Merrill's principle. Merrill merely insists that demonstration phase must be present in the instruction design. So, that is the idea of demonstration principle. We would like to acknowledge the help from faculty from our earlier workshops. Several colleagues who participated in our earlier workshops provided several examples, and they kindly permitted us to use them wherever necessary. So, we gratefully acknowledge the help from the faculty from our earlier workshops and Gen AI tools, including ChatGPT 4.0, in generating examples and associated figures. So, in the next unit, we'll continue with Merrill's first principles of instruction, and we'll complete the remaining principles and look into some of the critiques of the Merrill's principles, and then conclude the Merrill's first principles of instruction. Thank you. We'll meet again with the part 2 of Merrill's instructions. Thank you.